Let's have a look at the exponential function. There's the basic curve for it. Always goes through 1 on the y-axis, well the basic one of course, because a to the power of 0 will always be 1. So that's the curve if the base is bigger than 1. If the base was in between 0 and 1, then it would go the other way. And we don't have negative bases. It doesn't make sense with exponentials. Domain, as we can see, all real x, there's no breaks in it. And the range y is greater than 0. The other thing to keep in mind, if I was to draw y equals function negative x, what effect does that have on a graph? Function negative x. Right. So reflecting the y-axis. Therefore, that means that red curve could also be a to the power of negative x, but when the base is in between 0 and 1. Because if you were to reflect that red curve over, you'd end up with the blue curve. And that also therefore means that the blue curve could be a to the negative x when a is bigger than 1. Because if you were to reflect the blue curve, you get the red curve. Now, the log function. Remember, logs are inverse of exponentials. And what did we see if we had those two graphs on the same number plane? Inverse and the actual function. What do we notice? Yeah. So it reflects in y equals x. So therefore, the domain becomes the range becomes the domain. So we just saw that the range of the exponential was y is greater than 0. So therefore we're expecting the domain of the log function to be x is greater than 0. We saw that the domain of the exponential was all real x. Therefore the range for the log curve should be all real y. And we'll end up with something like that. So a reflection of the exponential curve in y equals x. But once again, that's when the base is greater than 1. If the base was in between 0 and 1, we'd get the blue curve. If we had to draw y equals the log of 3x, well, one way of thinking about it is using our log laws and saying, well, that's log 3 plus log x. So we've got the basic curve y equals log x, but then we're going to shift it up log 3 units, so go a bit higher. It still looks like your basic log curve. It's just that the x-intercept now, instead of being 1, it's now 1/3. If I was to do an exponential, 2 to the power of x plus 3, so our basic exponential, but this time we're going to have our horizontal shift because it's grouped with the x value. So we'll shift this one left 3 units. There we go. And so it'd end up with a y-intercept of 8 now. Log of the absolute value x. So function absolute value x. What did that do to a graph? So we have our basic curve. Whatever's on the left would disappear. Well, in this case there's nothing there anyway. But whatever's on the right would reflect over. So there's log of the absolute value of x. So all those sorts of ideas we saw in graphing still apply. So 8F, 8G, as always, enjoy.